In this video, we look at this MIT integration B question. This appeared in the 2025 regular season. So we can start off by really looking at this integrand. So let's expand few terms of this integrand. The integral from 0 to 2 pi of, so let's expand few terms of this integrand. So that is going to be putting in 0, that is going to be cosine of x, right? Because 2 raised to the power 0 is 1 plus, if you plug in 1, that is going to be cosine of 2x over 2, plus you plug in 2, that is going to be cosine of 4x over 4, plug in 3, that is going to be cosine of 8x all over 8. And this one continues until infinity, right? And we are squaring this. So this is the major problem, right? So if we are squaring this one, before we proceed with the video, we have to know this. If we are squaring, let's say a plus b plus c, this one is a squared plus b squared plus c squared plus 2 times the cross terms. The cross terms are ab plus ac plus bc. This is how to square a plus b plus c. So this one here can be likened to the a plus b plus c case, right? But we have infinite sum here. So with this one, our integral is going to be there's the x here. Sorry about that. So the integral from 0 to 2 pi of, so we are now going to square this term. So the first term is going to be cosine square of x. Next term is going to be cosine square of 2x over 2. Next term is going to be cosine square of 4x over, this is 4, because 2 squared is 4, 4 squared is 16, plus the cosine square of 8x all over 8 squared is 64. This one continues until infinity. Then you have the cross terms, right? So the cross terms, the first one is going to be cosine of x times cosine of 2x over 2. So we are going to have a bunch of cross terms because this is an infinite sum, right? So you just have 2 times a bunch of cross terms. So the cross terms, we can't really write them because this is infinity, is infinite sum dx. So we have to know something. We have to know that the integral from 0 to 2 pi of the cross terms, so cosine of nx times cosine of another variable kx dx, this one is going to evaluate to 0, right? So whenever n is not equal to k, whenever n is not equal to k, the integral from 0 to 2 pi of the cosine of nx times the cosine of kx, this one is going to evaluate to 0. So the cross terms are going to evaluate to 0. The integral of the cross terms are going to evaluate to 0 because we don't have n is equals to k's, right? So these terms, when we integrate these terms are all going to run to 0. Next is now to look at these square terms. So the square terms, this is how we can write them. I is going to be the integral from 0 to 2 pi. The cosine square of x can be written as 1/2 into 1 plus cos of 2x, cosine of 2x, like this, plus 1 over 4. Cosine square of 2x can be written as 1/2 into 1 plus cosine of 4x, plus 1 over 16. Cosine square of 4x can be written as 1/2 into 1 plus cosine of 8x, plus 1 over 64. Cosine square of 8x can be written as 1/2 into 1 plus cosine of 16x. And this one continues until infinity. So dx. So these are the first 4 terms, right? So I is going to be the integral. So before we proceed with the integral again, we have to know this, right? We have to know that the integral from 0 to 2 pi of the cosine of nx dx, this one is going to evaluate to 0 for any positive value, positive integer of x, right? Positive integer of n. So n are positive integers. So this is going to evaluate to 0. So in that case, if you are integrating this, this is going to evaluate to 0, the same as this, same as that, the same as this, and the terms beyond cosine of 16x. So what we are left with is the integral from 0 to 2 pi of 1/2, that is 1/2 is left here, plus 1/4 times 1 over 2, that is going to be what? 1 over 8, plus 1 over 16 times 1 over 2 is 1 over 32, plus 1 over 64 times 1 over 2 is 1 over 128. This one continues until infinity. So this is what is left after the expansion, because these terms are going to evaluate to 0. The integral of those ones are 0. And now these ones are just a bunch of constants, right? So you can just integrate this. So I is going to be, integrating this one is just going to be the constant, which we'll write again, plus 1 over 128, and so on and so forth. And then x, we are integrating that from 0 to 2 pi. So this one is going to be 1/2 plus 1 over 8 plus 1 over 32 plus 1 over 128, and so on and so forth. Then 2 pi minus 0, that is going to be 2 pi. That's just plugging in your limits. Now the task now is to find this infinite sum here. What is this infinite sum? What does that one sum to? So that is a geometric series, right? Sum of a geometric series. So the infinite sum of a geometric series is a over 1 minus r, right? So a is the first term, which is 1 over 2. That is the first term. And r is the common ratio. The common ratio here is 1 over 4. It's 1 over 4 because 1 over 8 divided by 1 over 2 is 1 over 4. And then we have 1 over 32 divided by 1 over 8 is 1 over 4. And then the last term, 1 over 128 divided by 1 over 32. This one is 1 over 4 as well. So 1 over 4 is a common ratio. So the sum to infinity is going to be equal to a, which is 1/2 divided by 1 minus r is 1 over 4. So that is 1/2 over 3 over 4. And that is 1/2 times the reciprocal 4 over 3. And that is equal to 2 over 3. So this one here will sum to 2 over 3, right? So our integral I is going to be the sum of this times 2 pi, and the sum of that is 2 over 3 times 2 pi, and that is equals to 4 pi over 3. So this one is the value of our integral. So if we integrate this one, the integral from 0 to 2 pi of the infinite sum of the cosine to the 2n x all over 2n all squared. This one evaluates to 4 pi over 3. This is the value of our beautiful integral. This is how I can solve it. If you have an easier way of solving this, make sure to give a comment in the comment section and let me know how to solve this. So anyway, that's it. Thank you so much for watching this video. I will see you in the next one. Bye bye.